Oh, we have a quiz
0 days
next
since
week.
you thought about a duck.
Yeah, but not this week.
Oh, no.
There's been 0 days since you thought about a duck.
Oh. That is true. I don't think about ducks every day.
No, it's been 0 days, because now you thought about a duck.
Today you did.
Friday.
What's up?
Not gonna be here on Friday.
Yeah, that's not good.
Oh yeah, I'm not going to be on Friday either.
Big yikes. So remember when I said like easier stuff this week, harder stuff next week? Turns out it's just harder stuff in general.
Perfect. This is my photo.
No.
I have to get my wisdom.
Oh.
All right.
Are you getting knocked out?
Got a lot to get through today. I've got more presents for you. We're gonna skip around a little bit. I've been trying to like give it out in sections. That way, if someone's absent, like Ellie, they don't get like, here's 10 pages all at once. Oh my God, right? I mean, it's the same thing. We'll take it slow, but kids are dumb. So I've been giving it to you in sections.
Mr. Barry, why are we really on Friday? It is the 14th.
And then we have Monday off after that.
Wait, we
got Monday off?
Yeah.
We will have this Monday off.
Does that mean all similarities?
Right.
Is that the upcoming Monday?
No.
Let's go.
That Monday.
President's Day.
Oh, okay. This Friday we have
Next Friday.
TC.
Oh, okay, this Friday.
Wait, so do we like not have a quiz?
Yeah.
Do we have
Wait, so do we not have a quiz this time?
No, we don't. It's next Thursday. Great.
Does
Next
that do
Thursday, you take my
the
quiz.
Wednesday dismissed Friday?
Whoa, big room. Wow.
Or are you saying?
No.
We're live.
Now I don't even get
The rainbows.
In honor of Triangle Squiggles,
Oh no.
I have to show you this.
Oh dear.
You asked for it. A whole page devoted to the rainbow sponge. The Army of Arts and Crafts.
Oh my God, why are you playing?
Shut up.
I
won't ruin it.
Shut up.
Dense. 3 sizes because I can't stand just one size. Another thing that I want to talk about is
Shut up.
I won't.
hygiene of the sponge. I squeezed and squeezed and squeezed and squeezed. No flab on this arm. My cleaning. Flab on this arm. Now, if you do get it on your hands, gloves are incredible. I have a pure glove sponge that is absolutely pure. Oops, a virgin edge. Oh my gosh. Ah, I'm sorry. Oh, I want you to look at all of those wiggles. Oh my gosh, wiggles. Oh my gosh. I love to wiggle the whole thing. There are many other surfaces that you can sponge on. I'm sure you would. Of course you can go straight. Are they incredible or what?
Just put dates on a sponge.
And it's done. Yes. Do you see that? Oh, earth tone. Look at that. Is this fun or what? Look at that. On a card. Really heavy. Yes. Yes.
Get it, Grandma.
Oh my gosh.
Is this
Now,
a family reunion?
think, go this way, and now we think, oh my gosh, oh my gosh. Okay, time. And then, oh, this was one night that I did not sleep. It is so hard to stop.
All right. The actual commercial is like an hour and a half long. It was an infomercial for the rainbow sponge, and somebody cut it up and got the highlights of it. So when I think of triangle squiggles, right, with the similarity, I cannot help but think about this video. And now you know what I'm referencing, and we're all on the same page. And yes, this is an ancient thing from when the internet was much younger,
The internet still won.
and nobody in your age really knows about it. So I figured I had.
I knew about it. Get on my level.
All right.
I'm 10 years late.
I think it's pretty funny.
I am 20 years late.
That grandma is amazing. Like, they made the commercial and they're like, who are we going to get to do this commercial? Oh, I know, let's get Deb, right? So,
Debbie Fredit?
no, not that.
That slightly reminds me of one.
Isn't that amazing? Like, that happened. That's like up there with the slap chop guy.
Dude.
All right, you guys know what the slap chop is?
No.
All right, Google it on the rest.
Maybe we should
What is
air
it,
this
Slack
online.
chat?
Yeah. All right, so
We should stop airing this.
we're gonna skip to number 6 today. So turn to page 5, number 6. Or wait, hold on. For homework, did I give you number 4?
No.
I did not.
No, you said wait.
Or did I give you number 3? 3 for homework, right?
You did 3 and 1.
We did 3 altogether? You did make it through? Okay, good. Good job, third hour. All right, so let's talk about 6. I'm jumping around a little bit because I want some intermediate stuff before we jump into number 4. Number 4 is a beast this
I'm
first hour
snagging it.
found out. So I'm going to easy into it. All right, so the plan, as you can see up on the board, is today's the 5th all day. We're going to be doing triangle similarity up until Wednesday. Because we had an early dismissal, I don't want to give you a quiz on that because it's going to be a super quiz, right? We're talking 2 weeks worth of material here. I'm going to do on Thursday, and we're going to review on Wednesday. When we have our dismissal, classes are 30 minutes, so I think we'll use that to grade it the next day.
What the heck is that thing?
The what?
0 days since you thought about that.
Facts. 6. All right, so it gives us that AC and BC are the same thing. So we have this alarm bell should be going off as soon as I do that, right? They also give us that ED and AC are perpendicular. So here's ED and AC. That means they hit at 90, right? And then EF and BC also hit at 90. Some beautiful boxes there. All right, so that's all we got. And now we want to prove proportionality between sides. That's what this means, right? I mean, it's division, right, and an equal statement. But what it really is the proportion, right? 2 ratios being compared. So we want to say that AD, this piece right here, is proportional to BF. The same way that AE, this bottom piece, is proportional to BE. So what we're going to do is we're going to use CSP. Remember, it's not CCP anymore because they're not talking about congruent parts, we're talking about similar parts. We're going to prove these 2 triangles similar, and then use CSP to say their parts are similar, right? Remember, when we talk about similarity, angles will be the same between triangles, right? 2 similar triangles will have the exact same angles, but they'll have proportional sides. Did you not get one? Yeah. Okay, cool. So, once we've proven triangles similar, we can say that their angles are congruent, right? Just like we've always been doing. And then we can say that their parts are proportional. And that's what this bit up here where it says prove means. So when triangles are similar, we won't be saying side AC is congruent to side BC or something like that. We won't be doing that, right? What we'll be doing is saying that they're proportional. We'll be writing something like this. Okay, so let's get comfortable with that. So, again, I marked AC and BC congruent, so alarm bells should be going off. What are we going to do first?
Oh.
What theorem?
Or just.
Isosceles triangle theorem, right? So we have isosceles triangle. So that means opposite angles will be congruent. So this angle here and this angle here are congruent. So by isosceles triangle theorem, right? This is from last week. Angle A is congruent to angle B.
Already?
I think I did too.
It's fine.
So far, so good?
Everybody's
Right.
gone.
I'm waiting to go in.
Yes, but we're going to be
Also,
okay.
I got this watch.
Make sure you're paying attention to this time. This is crazy, ridiculous stuff. Do not get sick. Oh my God.
I feel like that's
Courtney came back after missing one day and she's completely lost. God bless you, Courtney. I'm sorry. It's like in the zombie apocalypse, they get bit. It's just like they're just gone. That's it. There's
That's
nothing
when
to
you
do.
kill them.
There's nothing you can do.
Nothing.
You want to save them, but it's
It
just
is.
over.
No.
If they get bit by
Sorry,
a zombie,
Courtney.
you kill them.
Nothing, no.
If you get sick, just drop out. All right. So these 2 angles are
High
congruent.
school.
Now, recall from the other day,
Your mom would not.
to prove similarity, whoops, sorry you guys can't see that. To prove similarity, we need 2 angles to be the same, right? And we can use angle similarity. We also have all 3 sides being similar. Remember, that doesn't mean all 3 sides congruent. It means all 3 sides proportional, right?
We have something.
And then we also have side angle side, which is like a combination of the 2, where you have one matching angle where the angles are congruent, right? And it's surrounded by 2 proportional sides. Okay? This is what we got. Now, did they give us any information about the sides at all?
Can we do that?
No. So we're probably not going to use either of these 2. We're going to do double A, right? We have 2 triangles with congruent angles there. So we're going to say by angle similarity. Again, don't forget your squiggle, right? We're going to say that the triangles are squiggle. So ADE is squiggle to this triangle. Now we need to match up the parts. Notice that A, this angle here, matches up with B, so we can write that. D matches up with F, and then E must go with itself, right?
Yes.
Okay, cool. So now that we have the triangles being similar, we can say by corresponding similar parts, CSP, that their parts are similar. Remember, when we say parts similar, we mean that the angles are congruent and that the sides are proportional, right? When we write proportionality statements, we're going to write it like that, not like AD congruent to AE or anything like that. It'll be this junk, okay? So get comfortable with that. Angles, same thing. It'll be congruent. We'll be saying that like normal. So we want to prove that the parts are proportional between these two triangles. So the way to do it is use CSP, right? So I'm going to zoom out just a little bit and say by CSP, which you can only use after you prove the triangle similar, which we just did, right? Their parts will be similar. Which parts? Well, the parts that match up, the parts that correspond, right? That stands for corresponding similar parts. So AD will be proportional to BF. See how they're proportional? They're both in the same relative spot. They're corresponding. AD and BF are first and second spot, right? And that will be proportional in the same way as DE is to FE. It's okay, I'm doing extra steps. I'm being through.
Oh, yeah.
And AE is to BE. So when I write this stuff, I almost always start with the left side triangle and put that part on top. And then the right side triangle I put on the bottom. Remember, you can't mix and match left side, right side triangle. So if you're going to put AD on top, then DE and AE are going to be on the top as well, right? Don't just flip them random. Now, they're proportional. How are they proportional? I don't know. Is that one twice as big as that one? Is it like 0.5 as big? I don't know, right? But we know that they're proportional, right? There's going to be some number that relates them. So now, look up here. What?
So what do these like fractions of letters mean?
Okay, great. So if the triangles are similar, and they are, then we can say by corresponding similar parts that angles will be the same, right? We have matching angles here, 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 and here, and then we also get these. We could do that if we wanted, right? It's kind of like CCP. And then we can say that not the parts are congruent, like the sides. We can't do that because they're not congruent, right? They're proportional, meaning that AD relates to BF the same way that DE relates to FE.
So the letters are lines.
Yes, they're line segments. If we don't put a segment over the top, it means the value of that segment.
Okay.
Does that make sense?
Yeah.
Right, we do little m, angle CAB, that means measure of CAB, right? This is measure of angle, or side AB, right? Does that make sense?
All right, yeah.
Okay, cool. So, the measures of these sides will relate the same way. Maybe this is 2 and that's 6, and then if this is 3, this would be 9, right? They're going to relate the same way. There's going to be some number that connects them. Do we know it? No, but we know there is a number that connects them. So what we're going to say is we need AD and BF, that's this part, to be equal to AE and BE. Well, I have that, so I'm just going to write, therefore, AD over BF equals AE over BE, and I'm done, right? Already had it. By the transitive property, they're together, right?
And if you don't have, you just multiply the
Yeah, exactly, right. Sometimes you'll multiply, moves things around, but again, we need an equation. So the job is to get an equation by getting similar triangles, right?
Easy.
And then move stuff around, okay? This one should feel okay. I hope most of you guys feel good about 80% of this stuff, okay?
Can I go to the basket?
Yes, you may, just not here.
5 maps.
So now we're going to move back to number 5. Things are going to get a little crazier. So congruent triangles, it's great. It's awesome. It's wonderful. Everybody loves them, right? They're the same triangles. Isn't this fun? But what's really more interesting is similar triangles, because then we can get relationships between the segments, and we can find out really unintuitive things, right? Oh, look, both those triangles look the same. Are they? Oh, they probably are. Can I prove it? Oh, I did, right? Why did I have to prove that? They look the same. Let's call it a day. But with similar triangles, you might not know that they're related somehow, right? Same thing with different parts in a triangle, like when we look at number 5. With very little information, we're going to be able to prove some very cool things about any triangle that we look at. So if you look at number 5, it tells you that D is the midpoint of AC. So that means this, right? E is the midpoint of AB. So that cuts that into 2 equal pieces.
What is that symbol?
And then F is the midpoint of BC.
Wait, doesn't that mean that?
That's what that stuff means, right? So what we're saying is, if you take the midpoints, D, F, and E, and you connect them all to make a triangle, there's going to be something special about that. Now, notice, this is a generic triangle. Is it an isosceles? No. Is it equilateral? No. It could be, right? It could be that the red and the greens are both the same, right? We could find that out later. We could find out that all 3 sides are the same later. That's an option. But it doesn't have to be, because we're treating it like it isn't, right?
So this will be true for any triangle. Any triangle you draw, if you connect the midpoints, this will be true. We're going to prove that. That the parts will be proportional. What parts? That AB will be proportional to DF. So this is going to relate to that. Same thing with this side and this. Same thing with this side and this. And how are they all going to relate? By 2. 2 over 1, meaning that this will be double this. Always, for any triangle. Right? This is a really cool theorem. It's called the, what are these called? Mid-segment theorem. We're going to learn what mid-segments are and all that stuff is, but we're going to prove that theorem right now. So whenever you have a bunch of mid-segments are just when you connect 2 midpoints, right? The mid-segments of a triangle will always be proportional to their opposite sides. This will always be half of that. This will be half of whatever this is, and this will be half of whatever that is. Not only that, but they'll also be parallel. So this side DF will be parallel to AB. That's really powerful stuff. It tells you about segment length, it tells you about angles, right? Because parallels have to do with angles. So this is a really useful thing. So we're going to prove that that's true for any triangle, because we have some generic triangle here, right? Are we cool with that? Here we go. This is why similar triangles are rad and congruent triangles are just okay. Similar triangles can do a whole bunch of stuff. So we're going to prove that these are proportional, right? And that they equal 2. Here's what I'm going to do. That's a lot to get done, right? I got to match this guy up with this, match that guy up with that guy with this. It's going to make my diagram a mess, and then I got to prove parallel for everything, right? Here's what I'm going to do. I'm going to say, look, this side and this side are really just the same thing as this side and that side. So if I prove the blue with DF, by similar logic, doesn't that go with this, right? It's the same dumb crap. I have an opposite side in a mid-segment. I have an opposite side in a big-segment. I have an opposite side in a mid-segment. If I get one, I get all, right? So I'm going to do a lot of, by the same dumb logic, the other ones go together, okay? So what I'm going to do is I'm going to focus on getting DF and AB related. I'm going to prove that they relate by 2 over 1, right? And I'm going to prove that this is parallel to that. And then by similar logic, I can get all the other stuff. Are we cool with that? Right? I need you here. So make sure you're paying attention. So here we go. All right, first off, let's take a look at this triangle. The one thing you should always be looking for is shared angles. So this triangle up here, right, shares angle C with the big triangle. Do you see it? Okay, same dumb logic with this angle being shared with this triangle and then the big triangle here, right? So again, it's going to apply to everything. I'm just going to do one at a time. So I'm going to say that angle C is congruent to angle C for both the top triangle and this big triangle. So angle C, congruent to angle C by shared angle. Everybody cool with that so far? I'm saying that that top triangle there shares angle C with the biggest triangle, okay? Are we cool with that?
Yeah.
So now, if you look, I have a matching angle, right, for the top triangle and the big triangle, and I have proportional sides. This side is not the same length as this side, right? That's just not true. I'm not saying they're congruent. I'm saying they're proportional. I'm saying that CD is half of AC. Does everybody get that? CD is half of AC. Well, isn't CF half of BC? So this side is proportional to this side, the same way that this side is proportional to that side. So here's what I'm going to write. I'm going to write that CD, the little side, relates to AC. Okay, so think about what that is. That's saying, oh wait, not, yeah, CD, this part right here, relates to the whole thing the same way, so that's an equal sign, that CF relates to BC. So again, what does this mean? I'm saying this side relates to the whole thing the same way as this side relates to its whole thing, right? They're both half. This is half of that, that's half of that. So if this was 3, how long would this be? Okay, and if this was 4, how long would this be? 8, and that's fine. We're not saying that this and this are the same, right? This could be 3 and 4, right? But if that's 3, then this is 6. If that's 4, that's 8. They're proportional the same way. And how are they proportional? We know. It's 1 versus 2. Now you might be saying, wait a minute. We just said 3 and 6 could be a possible answer, right? 5 and 10 could be a possible answer. But what do all those reduce to? 5 over 10, 3 over 6, 8 over 16, pi over double pi. Anything that these could be are going to reduce to 1 over 2. Does that make sense?
Yeah.
The relationship is always half, right? And again, I started with the small part on top, so that's going to be 1 versus 2. Does that make sense, that ratio?
You can
Okay.
flip those to get to
You could if you wanted, yeah, and that's what we're going to do in a second, right? So, notice the way I wrote it with small to big. I almost always do that just to keep things kosher. What I want is to flip for 2, right?
Not much.
So what I'm going to say is that CD and AC relate the same way that CF and BC do, right? But I'm going to flip both of those. If I have BC and CF, that's close to what I want, right? And then I've got AC and DC, or CD, that's close to what I want, but not quite. So I'm not going to flip yet, but I will. So now I've related those sides. So what I'm going to say now is by SAS similarity. SAS similarity requires 3 things. It requires an angle that's the same, right, between the 2 triangles. See how the top triangle and the bottom triangle have the same angle, right? And then 2 sides on either side of that angle that are proportional. Remember, sides proportional, angles congruent for similar triangles. So do we have matching angles? Yes, they both use the same angle, right? And on the left side and right side of that angle, we have sides that are proportional. I have 1 versus 2 here, and 1 versus 2 there. So both of those sides are proportional to each other. Does that make sense? Again, I'm not saying they're congruent because they ain't, right? But they are proportional, 1 to 2, 1 to 2. That's what this is saying. So I've got my angle that matches, right? And I've got my 2 sides that are proportional. They have the same proportions, 1 over 2. And so now I can say side angle side similarity, right? And that gets me that these 2 triangles must be similar. So the top triangle, which is triangle CDF, is similar to the big triangle. Now, when we write this, we got to match stuff up. Notice that C is this angle right here. It's shared for both, so it's going to be C over here.
Hey.
D is made up of the red side and the unknown side. So red side, again, it's proportional, right? And unknown side, because we don't know anything about the blue, right, is going to go here. So A is going to go with D. F is made up of the green side and DF, right? Green side and the unknown side is B. Do you see how I matched those up? Cool, cool. All right. So now that we've matched those up, we can use CSP to say stuff about the parts, right? So here's what I'm going to do. Again, my goal was to prove that this and this relates, right? Well, if the triangles are similar, doesn't DF relate to this, right? This relates to that relates to this, so this should relate to that, right? That's by CSP. So by CSP, I know that DF relates to AB by a half. Right? Because all of these are related by a half. So that side must be related by a half. Does that make sense? If this relates by a half, and that relates by a half, then the triangles are similar, right? And if the triangles are similar, all of its sides should relate by a half, right? Yesterday we had something like this, 3, 4, 5, and we said these triangles were similar because they all related by double, right? So if I know the triangles are similar, 3 is going to go with 6, 4 is going to go with 8, and I know 5 has to go with a 10, right? So that should be a 10 there. If that relates to this by double, and this relates to that by double, then this should be double, right? Down here. So if you want, you can mark that DF is the same thing as AE and EB, right? This part gets doubled down here. Are we cool with that? Cool. So now I know those parts relate. DF relates to AB, and that's what I wanted, right? DF and AB related. However, it's flipped, right? Now, DF to AB is half, right? DF is half of AB. Go B. If I flip it, I can say AB is double DF, right? So I'm going to flip that. Therefore, AB over DF equals 2 over 1, or 2, right? Cool. So first part of my proof done, right?
Yes.
I can do a little swag box there if you want, and then go on to finish the other part. I'm having you prove 2 things, right? So, does everybody see how that works?
Yeah.
Now, by similar logic, let's do that right now. By similar logic, so what you would do is just repeat all of those steps, but instead of talking about angle C, you talk about like angle A and the big triangle, right? and you'd say that this side relates to these. So by similar logic, I know that DF and AB relates the same way as the others. So DF relates to AB. Or actually, let's flip that. Let's flip that. AB relates to DF. I'm sorry, guys. I'm sorry. AB is going to relate to DF. Let me zoom out so you can see a little bit better. I know it's smaller, but you can hopefully see what I'm talking about. So AB and DF relate, right? We already have that. The same way that BC, that's this bit right here, right? The green part. What segment is BC going to relate to? If AB relates to DF, what's BC going to relate to? Yep, DE. I always try alphabetical order when I can, right? When I have the option, but it's up to you. Doesn't matter.
So
The same way that AC, that's the red part, right? The big red part, relates to what? EF, very good. And how do they all relate? By 2, right? Because I flipped it, so it's 2 to 1 or 2. Now, that means I can mark on my diagram that that is true, right? Let me zoom in. Let me zoom in. That this is the same as one of those, right? And that this segment over here is the same as one of those guys, right? It's a 2 to 1 ratio. For every 1 here, I have 2 there. Cool? All right. Excellent job, guys, for staying with this. This is not easy stuff. All right.
I know this doesn't apply to it, but can you do shared angles for B and A too?
Yeah, that's the idea. So by the same dumb logic, we could turn the triangle and go, look, shared angle. Whole triangle shares it. By side angle, side similarity. The right? But we're saying by the same dumb logic, instead of having to write that for all
Yeah,
3,
just do
right? It's the same
similar
dumb
logic.
crap. Okay, just switch the letters. Is everybody cool with that?
Yeah.
All right, we're not done. We got to prove these are parallel. Now, here's how we prove stuff parallel. We know about cap, right? If we have 2 parallel lines, we should be looking for corresponding angles, right? Cap converse says if we have corresponding angles that are congruent, then the lines must be parallel, right? Let me say it again. Regular cap, corresponding angles postulate, says if the lines are parallel, then the angles, the corresponding angles should be congruent, right? The converse of that is also true. If we have corresponding angles congruent, then the lines will be parallel. So what we're going to do to prove these lines parallel, DF and AB, is to prove that we have corresponding angles. So what I'm going to do is say by CSP, since this top triangle is the same as this bottom triangle, they're similar, right? Their angles should be the same. Remember, similar triangles have same angles, right? So I'm going to say by CSP, and I'm going to zoom out. I won't. By CSP, these angles should match up. So let's talk angles. If you look back up here when we said the triangles are congruent, angle CDF should be congruent to angle CAB. Does everybody see that, right? Because it's first, second, third, first, second, third. So I'm just going to write that. Angle CDF congruent to angle CAB. Right? Similar triangles have congruent angles. Right? Proportional parts. Right? Proportional sides, but similar congruent angles. So if I do first, second, third here, I can do first, second, third there by CSP and say they're congruent. Now let's look at our diagram. CDF is here. CDF, right? So that angle should be the same as CAB. CAB. I know you can't see the C, but you guys
You can do that.
feel me?
You can do that for the other side.
Right. We're going to do the same thing. So do you see how those 2 angles are the same? Awesome.
You just add.
I got that just from using CSP. Now, could I do it for the other side? Sure. Look at the other side. It's angle CFD, right? CFD is, don't do it. Look up here. We're not going to do it.
Don't do it.
First, third, second, right? First, third, second should be the same as first, third, second here. So CFD should be the same as CDA. CFD, CDA. So it would be true to say those angles are congruent. But here's the deal. How many corresponding angles do we need to prove lines parallel? 1 set, right? So why get both? Let's just say, look, I have corresponding angles. That means the lines must be parallel. So we're going to say by cap converse, right? Because we're doing kind of cap backwards. We know those lines to be parallel. What lines? We know that AB is parallel to DF.
And you can do by
by same dumb logic, repeat the process for all the others, right? It's like do what I just did, but with all the other sides, right? So by similar logic.
Is that okay if I do that? Just wiggle logic? Similar.
Yeah, it's fine. This is true. AB and DF are going to be parallel. What else is going to be true? Looks like
AC.
B, let's do BC next because that's what they have. BC would be parallel to DE, right?
You can do the same thing.
So BC, parallel to DE. And then we would also have that AC is parallel to EF. Are you smelling what I'm stepping? All right, we're going to take a little bit of a break, let you digest, but that's the idea. Okay? We're going to do the first half of the next one after we get done with our break. The next one's a doozy, but hopefully this has prepared you for it.
Is it in the packet?
Yeah, I said we're going to do 4 hours.
Oh, yeah.
All right, so
Oh, this is
let's talk. Let's back up and go over it again. All right, I wish I could have like an intermediate Zoom, right? But I don't. All right, so here's what I did. I said shared angle for the top triangle and the big triangle, right? I know these sides are proportional because that's 1 to 2, 1 to 2. So if I have proportional sides and an angle in between, I can say side angle side similarity. Triangles are the same. Pardon me, triangles are similar, right? If the triangles are similar, I can use CSP to say that DF and AB are proportional the same way the other ones are, right? I can flip that and make it 2. That's fine. There's no problem with that. By similar logic, blue sides are going to be proportional 2 to 1. Greens are going to be proportional 2 to 1. Reds are going to be proportional 2 to 1, right? That's up to there. How do you feel about that? Okay. Then I can say also by CSP, right? Since this triangle is the same as this triangle, right? Similar, I should say. Angles should be matching, right? Which angles? Well, the ones that correspond, right? I can check by looking at the letters. CDF should be the same as CAB, right? And if I have 2 corresponding angles, look, 2 parallels, right? If those 2 are corresponding, which they are, they're in the top right corner of their intersection, then those 2 lines must be parallel. How do you feel about cap converse? Are you feeling okay about that? Right? If I were to extend these out, we don't know they're parallel yet, but we have a line cutting 2 others, right? So that's a transversal. And we have corresponding angles, right? They're in the same relative spot, and they're congruent. So that means those must have been parallel lines, right? Are you okay? You left at a bad time, bud. The transition from 6 to 5 was kind of key. Are you all right?
I'm sick, I think. I'm not feeling
Yikes. Yeah, everyone's getting sick. Now is not the time, guys. Like and subscribe. It's your only chance. Either that or drop out. All right? We're up to 72 subscribers, I
Should I
think.
go put this up here, Mike?
No, we're not doing ASMR today. All right. Okay, relax for a couple seconds.
I want to sleep.
It's a lot of steps, and I feel like I'll forget one.
That's okay, that's okay. We're going to have way more practice with this, right? And I think it kind of flows eventually, right? The idea is we're going to match up triangles to be similar, right? And then use their parts to prove what we want. It's very similar to doing congruency, right? Get the triangles congruent, and then use CCP, right? Now it's get the triangles similar, use CSP. Remember that angles in similar triangles are all the same, right? And parts are proportional. That's the weird part, which makes it difficult because it's weird and it's new. But I think eventually it'll get in the flow of it. I really do. All right, new pictures are in for the, like your pictures you took like a couple months ago, right? For your, this year instead of last year. The old pictures were in for attendance, and so when I go to take attendance, I do the scene chart and everything, get your new pictures in. Your hair looks amazing in that picture. It's all like curly and crazy. It's amazing. Everyone should see it. I should put it up on the board.
No. Yeah. No.
But it's all so great. It was just like, I didn't know about it. Just one day I opened it up like I normally do to take attendance, which I rarely do. I should be much better at that. And then there you guys are. It's like, oh, this is my baby now grew up. It's so sad. I miss you guys.
Please teach it. Please teach it.
Nope, not doing it. I refuse. I wish I could, guys. But I can't. Unless less drastic things happen over the summer, that's not going to happen. And I kind of prefer not to, because like I just got this figured out with all the homework assignments and everything. I'd like to not have another crazy year.
Next year I'm gonna have to do double D's.
But you guys can come in and for homeroom. I'm one room down.
That's gonna be.
Next year.
Or
That's
two.
gonna
I don't know
be-
if Royer teaches it or if Andrew might. I don't know. But either way, I'm here. I want to see you. I know it's awkward when you come back. It's like when you talk about it and all that stuff. But like I really want to see you guys. Please come back. Nothing would make me happier. All right, let's look at 6.
Go on.
Not 6. 4. 4. 4. All right. Are you ready for this? Woo! Woo!
Better not be on.
That's good. All right. All right.
No.
Here we go. We're gonna try some of it today, and we'll see how it goes. Okay?
Jessica has a question.
Who has a question? What do you want, Jessica? You don't have an original, an OG packet? Is that what you said? Okay. Let me find you one. It's somewhere in here. Could be anywhere.
For Spanish too? I'm not taking no Spanish. I'm not.
No te gusta español?
I'm horrible at Spanish.
Then get better at it.
I can't.
I'm incapable. I memorized. I get something down in Spanish, and then my brain just like.
It's like I can do it.
Oh,
As soon as the
man.
test
What
is
extra
over.
copies
As soon as
do
the
you
test is
want?
over. It's like,
Right, and then it comes back, and it's like.
it's like you don't know how to do this anymore.
Jessica, here's the original worksheet. All right.
Too, then you get more. You get present tense too.
Here we go.
You get something.
Number 4. All right. First of all, let's talk about what this means. What? It's part of the packet I gave you. Not today, but the one from yesterday.
Yes,
I have
So
translation.
Remember, today was just an extension on the packet, right? So you can staple it in there if you want. We're on number 4.
well, that's why you did.
It should be page 3.
I'd probably on the
If you need another one, I've got one for you.
Is this, oh.
Are you good? Okay.
You're not
So guys,
really okay.
I've been releasing the big packet in like sections. I released section 2 of it today. It's all the same thing. Okay. We're going back to section 1 because I decided this one was a little too. We were like cruising along. Oh look, similarity. Use AA or double A and we're done. And then it's like this behemoth. And I was like, maybe we should we should crawl before we like downhill ski, right? Yeah.
Before we all go.
Oh yeah, you're on. You're on. All right, so let's talk about what this means. Don't get too far ahead because there's gonna be a lot of information you can get, but we're gonna try to make it streamlined as possible. Okay. That way we don't have a million things in our diagram. There's lots of true things you can give me. Remember the other day when I asked you, tell me about the triangles, right? Try to tell me tell me stuff that's true, but not what I want to hear.
Yeah.
That's like doing proofs, right? Look at all this true stuff I got, but I have no idea how it helps, right? We want to get used to feeling that way, but right now we're going to streamline it, okay? So, D is the midpoint of AC. Everybody agree with that? Okay. E is the midpoint of BC. Do we know AC and BC congruent? No, we do not, right? So these are two different sides as far as we're aware, right? So they're two different halves. Red halves and green halves. So, is this triangle isosceles? It could be, right? It could end up being, oh look, the reds are the same as the greens, right? You find out later. But we're not specifying that. This is a generic triangle. So this is going to be true for every triangle. So what does this mean? It says that BF and DF relate. So here's BF. And here's DF. So we see how it splits that line into two pieces, right? And AF and FE are split. So if we connect a vertex to a midpoint, and a vertex to a midpoint in a triangle, and we cross them, right? When it intersects, it'll divide up the segment. How will it divide it up? Into a ratio of 2 versus 1. So what does that mean? It means that BF will always be double DF.
So it's 1, 2.
Any triangle you draw, if you connect a vertex to a midpoint, where they intersect will break up these segments into 2 versus 1. So if that's 6, that would be 3. If that's 8, that would be 4, right? This is a really powerful idea. if you know this theorem, because we're going to prove it, right? It's going to be a theorem. Then whenever you see something like that, you know those are midpoints. Oh, easy. That's double that, right? This double that. We're going to prove why that's true. And this works for any triangle, any generic triangle, right? Cool. So as long as those are midpoints, if we're connecting vertex to midpoint, they're going to intersect. And where they intersect will break up those segments into 2 versus 1. Okay? That's what that means. So we're going to prove that. So first thing you should look for is, hey, where can I get some similar triangles really quickly? Top and bottom, right? I think we are used to by now seeing that that angle is shared for the top and the bottom, right? So by shared side, or shared angle, sorry. I'm used to saying shared side. Angle C is congruent to angle C for both of the triangles, right? Okay, now, that tells you we've got proportional sides, right? And an angle in between them. So we can use side, angle, side. Now before we do that, we have to state that the sides are proportional. So what we're going to do is we're going to say, look, CD relates to AC, the whole thing, right? In the same way that CE, I mean green, CE relates to its whole thing, BC, right? And how do they relate? We actually know, right? 1 versus 2. Small versus large. That's why I did the small part first, right? 1 over 2.
Big thing.
So we've proven the side's proportional, and we've proven the angle's congruent. So we have proportional side, angle, proportional side. You with me on that? So now we can use side, angle, side similarity. By side, angle, side similarity, the small triangle, CDE, will be similar to the big triangle. C goes with itself, D goes with A, and E goes with B. How do I know that? Because D is red side and unknown. CA is red side and unknown. So those angles are going to go together. Okay? So now that we've got that, here's what we want to do. Do you see how we want to know about this segment and its pieces and this segment and its pieces? We're going to prove that this triangle here in the middle is similar to the one at the bottom. Okay? Because if they're similar, in the same way that these are similar, right? This is 1 versus 2, right? This would be 1 versus 2. 1 versus 2 is what we want, right? You guys see that? I want to prove that this is 1 versus 2. Right? Does that make sense? So I'm going to prove that this triangle is similar to this triangle in a 1 versus 2 ratio. So to get that, I can do double angle, I can get side, angle, side, or I can get side, side, side. Spoilers, you're not going to get side, side, side. That's one really hard to pull off, right?
Wait, why?
To get all the sides to be to proportional, it's just a lot of work to get it done. We're going to go for angle, angle.
Shared sides or whatever.
We do.
These guys don't share a side.
Oh yeah, never mind.
You see what I'm saying? Shared side is they butt up against each other. Exactly, yeah. All right, so we have vertical angles. That's true. So that we can get a free angle there and there. I'm not going to do that just yet, okay? But that's true. We can get a free angle there and there, right? Here's what we're going to do. We are going to prove that this is parallel to that, and then get corresponding angles here and here, and then vertical. So I'm going to prove that those two angles are the same, and those two angles are the same. So how do I prove this line and this line parallel?
By cap converse.
Well, if this angle and that angle is the same, right? Cap converse, they're parallel. How do I get this angle and this angle to be the same? Zayden. CSP. We know this is similar to this, right? So the parts should match up. So angle CDE, right? CDE, you with me? Should be the same as CAB by CSP.
Similar or congruent?
Congruent. Those angles will be congruent. Remember, similar triangles have congruent angles, but they have proportional sides. So by CSP, I know angle CDE is congruent to angle CAB. Again, first, second, third is what we're doing. It's convenient they're in the right order here. Makes it a lot easier. Good job, Mr. Matt.
Then by cap converse?
Now, by cap converse, we know those lines to be parallel, right? So by cap converse, segment DE is parallel to segment AB.
Easy class.
Feel okay?
Yeah.
All right. This is no joke. So now that they're parallel, right, we can get these angles for free as well.
Should we?
Here's what I'm going to do. I'm going to wait on that. Yeah, I'll wait on that. So here's what I'm going to do.
Should we put that little symbol?
I'm going to extend my parallels now. Yeah. Let's do parallel. So I'm going to draw this out and write parallel symbol, right? I'm going to write this out and write parallel.
I wrote it.
Okay, that's fine. And then when I extend it, I extend it into something. So we're going to use a lot of letters for this one. So I'm going to start the alphabet backwards. Z, Y, X, and then W. I don't want to start at the beginning because I've already done ABC and all that stuff, right?
H.
So we're going to say let Z, D, E, Y, and let X, A, B, W. All right? I'm also going to extend one of these transversals. So I've got lots, right? This is a transversal cutting two parallels. This is a transversal, right? But what I care about is making that angle and that angle match up. So I'm going to extend this transversal. Okay? I'm going to extend this one. I left off at W, so I'm going to use V and U. So let there also be V, D, F, B, U. Woo! Alphabet soup in here. All right.
Ran out already?
All right, here we go. Yeah, right now. So I got to put them on when you're done. Check it out. Two parallels cut by a transversal.
Oh.
So by cap, that angle and that angle are the same. You with me?
Yeah.
Are you with me on that?
So like that.
So by cap, can you see what I'm writing?
Yeah.
No? Oh, yes, okay. EDF is what I'm going to call that top angle. Congruent to angle WBU. Are you smelling what I'm stepping in? Now, that angle down there doesn't tell me anything about the triangles I'm interested in, right? So how can I get that angle to relate to an angle in here? Vertical. Are you with me on that?
Yeah,
So now we've got this. I'm going to color these in so it's easier to see.
I was doing that way.
I would encourage you to use colors, otherwise you're using like triple bands, double bands, quadruple bands, right? That's, right? I did that on the other one. It was bad. It was real bad. I had like bands going out to here. All right, so these angles are congruent by vertical angles. So I'm going to just write that here to say congruent by vertical angles theorem. Angle WBU that I was talking about earlier is congruent to angle FBA. All right. We've got one angle in each triangle matching. If we can get one more, we win. And we know how to get that last angle, right? Could we do the same thing over here? Sure, right? Those will be the same. Same dumb logic, right? Or again, you could do it, that's fine. By same dumb logic, these two angles are the same, right? Or we could just go for the easy pickings and say, look, vertical angles, bud.
So I was way.
So I just left it for later. But you could have done it earlier. By vertical angles theorem, angle DFE congruent to angle BFA.
DFA.
BFA.
Oh, probably should color.
BFA. That's
And
a
then
B.
what was the other one?
DFE.
No, the ABC is congruent to FBA.
All right. Tomorrow we'll finish it. If you want to try finishing it on your own, you can.
Yeah.
We're almost done. Excellent job today, guys.
Now I got it. Spanish.
Show up hungry tomorrow. Not literally.
I have art. Want to do my clay project? Can I?
Nice job today.
How about it?
Yes.
I still think you should just make it bigger.
I'm out of actual patterns. Bye, Jess. Once you get it, you feel like a frickin' genius, right? But getting you guys there is going to be the hard part. But I think we've got it.
Don't
You
I
guys,
have
you
it?
guys kicked some major butt today. Third hour.
I think I might have it already. Just because after that you go